Hi folks, welcome back. I hope you're all doing well. In a previous video on this channel, I'd looked at Microsoft's GraphRAG system, and that was a great representation of how we can improve RAG retrieval augmented generation by pre-processing our corpus to extract conceptual knowledge from it. And that was in the form of graphs with nodes being concepts and edges being relationships among those concepts. The paper today does something similar, but I think the interesting thing in this paper is how they use agent-like behavior to traverse the graph, reason over it, and generate answers. The main advantage of this approach, as the authors state over here, is that while using a much smaller part of the context window, only 4K, they are able to generate higher quality answers compared to models like GPT-4 with a 128K context window. And the way they do this, as we'll see, is that they're able to traverse the graph and pick out the highly relevant parts required for answering the question. So that lets them not include a lot of extraneous stuff or the entire document in the context. This diagram explains the entire process end to end. The first step, which is done offline, is to construct a graph from your documents. And the way they do this is by using an LLM like GPT-4 that is prompted to take in a document and output a knowledge graph of the concepts in that document. So here you'll see an example with places and people and concepts and how they're related to each other. Then, when it is time to query this graph to answer questions, they use a fairly elaborate agent-like workflow to traverse this graph, and they do multiple steps of reasoning. So the first step is what they call pre-planning, where given the question, they prompt the LLM to come up with a plan for answering that question. Once you have that plan, they look at the knowledge graph that they just extracted and select an initial node to begin their search for an answer. And while they're doing this, they keep a notebook, a scratchpad, where they note down what this agent has read that is relevant to answering this question so far. Now, once they've selected this initial node, they start looking at the atomic facts within that node. They explore neighbors, they decide which neighbors to explore, and all this while they keep updating their notebook with facts that are relevant. And finally, when the search has terminated, they use a termination condition. They use the notebook to answer the question. Now, as is common in most LLM papers by now, instead of using human evaluations, they use LLM raters to evaluate the correctness and quality of the answers. This table summarizes the results that they're seeing. They use benchmarks like Hotbot QA, Multi-Hop QA, and so on that have complex questions over a base corpus. And they're comparing several methods. They compare dense retrievers like BM25 with using the full 128K context of GPT-4, as well as using chunking or more traditional RAG with GPT-4. If you do chunking, you'll end up using a smaller part of your context window. The golden row down here is the best achievable answer. This is where they added the question and all relevant supporting facts directly into the context window. And here you can see how GraphReader does much better than GPT-4 with a 128K context window on all these benchmarks, and even much better than traditional RAG with a chunked approach. And Importantly, it does so while using only a 4K context window. A lot of the quality of graph-based approaches like this comes down to the quality of the underlying knowledge graph. So how good were the concepts and relationships that you were able to extract from the underlying document or corpus. And they use GPT-4 to do that. And here in the appendix, they have the full prompt used for extracting key elements, atomic facts, as well as the relationships among them from the document. This is the prompt that they use for pre-planning, which is to come up with a plan to answer the question. And here's the prompt for selecting the initial node to start the search from. So here in the appendix, they have detailed prompts for all these steps. So that was a quick look at GraphReader, which uses an agent-like approach to exploring a knowledge graph and answering questions about a corpus by utilizing that knowledge graph. Now, I will say one glaring omission in this paper was any citation or comparison with the Microsoft GraphRAG paper. We've covered that on this channel before, and I'll leave a link to that. But I think the main difference here is the agent-like behavior they use to reason over the graph in a multi-step way, and the way they maintain some short-term memory in a notebook while they're traversing the graph, and then how they use that short-term memory to finally answer the question. I think that agent-like behavior is the key difference from GraphRAG, but I would have liked to see the authors do that comparison in the paper. I hope you enjoyed that. If you like content like this, please like the video, consider subscribing, and I will see you all next time. Thank you very much.